seems that way. Okay. Oh yeah, I heard. He told me all about it. He did. I think derivatives a lot more fun than limits. That's a chain rule. In this case, will we ever get to 0? No. Thirty-six times 5. Anyone do that already? Thank you. Why not? Got to write it back in the form it was given to us, right? On the test. Yeah, on the test to do, and on your activities too. Okay, so that was the easy part. It's pretty easy. Do you feel like we should do number 3? Yes. Okay. Did everyone get that down? Sorry, I just want to make sure. Yeah, we're good? Okay, you need to wait? Okay. They taste good? Yeah? Oh, that's good to hear, because someone told me they're not that good. I wasn't going to buy them again.
They're not quite like those like brown and green ones that you get for Halloween when you're in like grade 5.
Oh, you mean the apple ones?
Yeah.
Those are the best. Those remind me of my junior high days. I'd buy one like every day. Okay, moving on. Good now, Vincent? Oh, almost. Okay, I can wait. Well, while you're waiting, why don't you try number 3? Okay. Good. All right, guess what we get to use here? Chain rule. Okay. Are we good with the chain rule?
No.
Derivative of the mommy times the derivative of the baby. Just like this is the baby inside. Right? Just carrying. No, okay. All right. So y prime. So first power rule. We get 1/2. What does the inside change? Nope. And what's 1/2 minus 1? -1/2 times the derivative of the inside. Now, some of you really need to be careful. When you times by the derivative of the inside, you need to wrap it in brackets if it's going to be more than one term. Right? So on your activity, it was like a trinomial, and the derivative of the inside worked out to be 10x plus 1. Okay? And a bunch of you did not put that in brackets, and that really changes the function, right? It has to be wrapped in brackets. So in this case, it's just, what's the derivative of the inside? 2. So you don't necessarily need that, but yeah. And okay, so if we write this, what does it become? What's a half times 2? 1. So that's gone. So just 1 plus 2x to the negative a half. Am I going to put that on the denominator to rewrite it? No, because we're going to, what are we actually looking for? The second derivative, right? Now we could make it the quotient law. I think that would be more work. We could just use the chain law here to differentiate this guy. Again, yeah? So y prime is the slope of our tangent. We graph all the slopes of the tangents. The second derivative would be this. Yeah? And then subtract 1 again, and then times 2. So you know it's, yeah, the 2 and the negative half will just cancel out. But it will be a negative now. So that's why it's better just to write it and then simplify. Okay, so writing this in the original form, guess where we have to put it? The bottom. The bears. That reminds me. Okay, and it's 1 plus 2x. What's the root? What index do we have? 2, and the top is the power. Power over root. Power over root. And there's our answer. Okay, now we take it to the next level. We're literally going to take this to the next level when we have implicit differentiation. And I'll show you why in a second. So let's differentiate this guy. Start by finding y prime. Let's not. No, let's. Okay, so 3x squared plus 3y squared y prime equals 0. Doing it twice in your head? Oh, okay. Oh, you mean the constant? Yeah. Okay, so subtract the 3x squared. We want 3y squared y prime by itself. And divide by 3y squared. So y prime is, or negative x squared over y squared. Do we need the 3's? Can we reduce them? That looks kind of ugly, hey? Let's try that again. Still bad. Still winning. Okay, so guess what we're going to use? Quotient law for our double prime. This is, okay, this is where it's going to get fun. It's looking for a second derivative. Okay, now, I did the quotient law too. Yeah. Let's use the quotient law. So derivative of the top. Negative 2x, leave the bottom, or times by the bottom. Then, what sign is it? Minus, leave the top. Well, if you're minusing times a negative x squared, it's actually become positive x squared. Derivative of y squared? 2y prime. Good. All over y to the 4. Okay, here's the thing. Let's first simplify this, but we were solving for y prime, and we want it in terms of x and y. We don't want it to have y prime in there as well. So how could I get rid of y prime? How can I make this a statement with just x and y's, no y prime. No. Do we know what y prime equals to? I'm gonna bring that to the numerator just to make it a little nicer. Why don't you go wash it in the bathroom? Okay. Okay. So when we're dealing with implicit differentiation, okay, Greg. And we have a y prime in our second derivative. We're going to replace it because we know what y prime is equal to. So we're going to replace it, and I brought it to the numerator just to make it a little bit pretty. I brought the y squared up to make it a negative x power. Just make it a little prettier. Is that okay? Okay. So this is times by negative x squared y to the negative 2. So let's simplify this guy. And it's going to turn out usually to simplify to something really pretty and simple. I'll show you how to get there. Oh, I got a chocolate bar problem too. You saw that? Oh, good. Okay. All right, so multiplying these together, we get negative 2xy squared.
Like you have to solve it first. You have to just solve it. How many chocolate bars do you grab?
Oh, it's as many as people do it. It's about a page to page and a half to 2 pages, depending how big you write. Oh yeah, like it's worth a full chocolate bar of your choice. Okay? Okay. Let's get this problem. We still have 2 problems left, guys. So 2 times the negative 1 is negative 2. X to the, what? Wiley, you want to put that away? Thanks. Y, x to the 4, y, what happens to the y? Y to the negative 1 all over y to the 4. So now we want to factor our numerator. So factor out the smallest powers as well as probably that negative 2. So I can factor negative 2. What's the smallest power for x? X. What's the smallest power for y? Negative 1. So what we're going to be left with is y squared divided by y to the negative 1. What happens when we factor out y to the negative 1? It's like subtracting negative 1. 2 minus negative 1 is y cubed. Plus, the 2's gone. And what's left over here? X cubed. I will tell you that we have seen this before. Where have you seen y cubed plus x cubed? No. No, keep close. Look at the beginning of the question. Look at equals 6. In this equation, x cubed plus y cubed equals 6.
I've been doing the wrong questions.
Okay, so we get negative 2xy. Let's bring the y down, guys. Let's bring the y down. Y to the 5 here. And we'll times this by 6. And so it simplifies to a beautiful negative 12x over y to the 5th. And usually you're going to end up having that substitution at the end. So beautiful.
But you could really, so I guess you could go like x cubed plus y cubed equals 6 and then just never have that.
Well, you couldn't do the whole, like you couldn't even differentiate it if you didn't have that.
That'll be hilarious.
Okay. All right. So cool. Okay, we're gonna try one more. I don't know if you have enough room, so write small. Or I think you could carry on to like the yellow part. Maybe you want to do this. Or not yellow. This is orange. Okay. Did you guys like the comic on the next page? Optimus Prime? Oh, so funny. Okay. Did you want to try this one on your own or just together? Together. Okay. So let's go. 2x. I'm just gonna make this happen. Well, yeah. Okay. You're right. Okay, differentiating. What do we have to use here? Product rule. So when you have a number in front, you can just like group that with one of the numbers. So you can also bring the -1 in front with the brackets like we did yesterday, but you can also treat it as -1x times y. Okay? If you don't want to have the brackets. So differentiating -1x, -1 times y, and then leave the first, so -1x. What's the derivative of y? What's the derivative of y? Y prime. Plus 2y prime equals, Greg, derivative of 3? 0. It's not 6. Okay, so let's get all the y primes in one side. I like to go straight to factoring out the y prime. So factoring out the y prime of these two, we have 2y minus x, and I'm moving 2x minus y to the other side. So I'm going to write that as y minus 2x. You with me? So we brought these guys to the other side, factored out the y prime from those two. This is kind of a funny looking function, hey? And there's our y prime. Or, yeah, relation, thank you. Mistake. Maybe over spring break I'll work on baking, and then I can have some time. No, but during the week, just like, you know how it is. That's crazy. Okay. All right, second derivative. Guess what we're using again? Quotient. Okay, derivative of the top is awesome. Derivative of y? Y prime. This is going to be so ugly. Minus derivative of 2x. 2. Leave the bottom. Minus. Leave the top. Times the derivative of the bottom. What's the derivative of 2y? 2y prime. Minus 1. All over. This is why you're going to run out of room. The bottom squared. You have to have that memorized. It's not on a formula sheet anywhere. Right? You should know it because it's a staple. Should be able to eat and breathe the quotient law. You're going to really need that in the future. Okay, guess what we have to do with this guy? Simplify. Get rid of the brackets. Okay, so it's going to have 2y prime minus xy prime minus 4y plus 2x. Now, if you feel confident in yourself, wait a second. We just foiled that, right? Good old foil. Remember when you learned it and you're like, why do we have to learn this?
No, I don't.
Okay. If you're feeling, what's that saying? Are you feeling lucky? No, is that not what it is? Yeah, from like Jack Nicholson or something. Okay. If you're feeling lucky, you might want to be brave and bring in the negative at the same time. Okay, so then if not, let's go like this. We're not the minus sign here. Right? We're foiling, right? We're expanding the numerator. Yep, okay. So y times 2y prime is 2yy prime. I know. That's why I said the orange paper. Minus y minus 2xy prime. Oh, caught it. I caught it. So minus 4xy prime plus 2x. Okay, so yeah, so I would have brought probably the negative in at the same time, but yeah, what's gonna cancel here? The 2yy prime, and if you subtract 2yy prime, it's gonna go. What else? 2x's. Good. So that makes it a little prettier. Not really. We already have an xy prime. Let's bring in that negative maybe, so we don't make a mistake. 1 prime. So the negative y becomes plus y, and the negative 4x becomes plus 4xy prime. Is there anything we can combine here? The y's and the xy prime. There's two like terms here. Did you give up on this, Greg?
Say I gave up would be...
The truth?
No, I'm trying to think of what it would be. Best to say.
Okay, let's look like terms. So 4 minus 1 is going to give you 3xy primes. I'm trying to simplify this before we replace our y prime. It's going to be ugly when I do. And what else do we have? Minus 4y plus y minus 3y. Okay, are you ready? Guess what we have to do? There's nothing else we can do. So what do we have to do? You could take out 3, but let's not even do that. We don't want our answer with a y prime. How do we get rid of the y prime? Sub in y prime. It's, yeah, maybe. Okay, so 3x times. Okay, and this is not even a chocolate bar question. I would say it's maybe a little chocolate bar question.
Is this like a activity on the test?
Yeah. But maybe it won't be as ugly.
It should be just this question.
Okay.
That's what it involves, like all of these. It's true. Like if you ever do this question,
Got a little chain law. You got a little different. You got a lot in there. Yeah, it's true.
maybe just make the test just like a y to a 3 one. Like
Yeah. Oh. Okay, marking that would like it would suck so much. Okay, so guess it. Okay, before we freak out here, because I feel like there's a little bit of panic right now, right? But we just want to get a common denominator here.
Like I know the outcome. I'm not gonna like you.
Right? So how do we do that? It's rational expressions. We can deal with that. It's just that we're tired and it's a long question. So I told you to do it on the orange section. No one listened. Okay. Y minus 2x minus 3y. We have to multiply top and bottom of that guy because we want a common denominator of the 2y minus x. So we're going to multiply him by 2y minus x. So all of him is under 2y minus x. And that's all over 2y minus x squared. So what can we do here? Multiply by the reciprocal, and what will happen? Guys, if you're not listening, do you want to leave? Okay, then, like, right? Because it's hard to talk over top of you guys. Where is this one? Okay, so that's this guy. I was getting a common denominator with the top. Because they're now both underneath 2y, right? So I multiply top and bottom of this guy by 2y minus x. So they have a common denominator here. Okay? Thank you. Can we make it under 2y x to the 3? Yes, that would be nice, a lot prettier. Okay? I know. It comes to a point where we're getting there. So the numerator, let's simplify that. 3xy minus 6x squared minus 6y squared minus 3xy plus, thank you. Okay, collecting like terms. I barely made it work on here. Okay, so we have 6xy minus 6x squared minus y squared. Okay, what can we factor out of that? No, just 6. Now we want to be careful because what do we want to create? Why? Someone said it, negative 6. Why do we want to factor out negative 6? So that equals x squared minus xy plus y squared. So we're going to factor out negative 6. And you know it's 3. Right, you're going to have the inside. Now, do you want me to write it? I'm going to write it on here just so people at home know what's going on. So x squared, we have a minus xy plus y squared. This is equal to 3. This is equal to 3. I won't forget. Okay, and negative 6 times 3 gives us negative 18. Isn't that beautiful? I know. If you find it, let me know. Actually, there is a program that'll help you check your answers. Wolfram Alpha. Yeah, if you're at home, that is like Wolfram Alpha. It's okay. It is incredible. It is an amazing application. So Wolfram Alpha.com. And so it'll do everything, guys. It's amazing. So if you're not sure about, like, there's examples. So say we want to go to math. Under the examples, I want to do derivatives. Calculus. So here's some different, so if we want to do the derivative, we type derivative of or second derivative of. So I would like to know the second derivative of, what was our function? It was x cubed, x squared. Oops, where's the hat? Shift, x squared. No, I said shift. Okay. Minus xy plus y squared equals 3. Why is it showing false? Step by step solution. I think because I have equals 3. Because we have an equation and not like a function. Why does it say false? Yeah, I'll differentiate that. Why is it doing that? I don't want to sign in with my Facebook. Do you have to have a sign in? Okay, well, I'll make something easier for now. It does do the solutions for you, and it does give you step by step. Apparently, you need to sign on with Facebook or something, but I'm not going to do that. It is an incredible app. If you're at home and you want to check your answers and how to work through problems, I'm not sure. I don't know, maybe the program is not set up for that, but. So that's it for today's lesson. That's it for the unit, right? Now, if possible, I'd love your assignments as soon as Thursday. I know that's early. If you give it to me by Thursday, I'll for sure mark it that day and then give it back to you before you write your test on Friday. We have 25 minutes, so let's use this time to either practice this stuff, do the chocolate bar question maybe, or work on your assignment, or work on Math 30 if you have or other stuff to work on. The end, let's say Friday. Yeah.